Year 2023, Pure Maths 1, question number 4. Let's try that. So we are given over here that a curve y equals fx, given that f dash x is this. So f dash x is given to us. The curve has stationary point with x coordinate alpha. So we have x coordinate alpha and alpha is small. Use this small angle approximation for cos x to estimate the value of alpha to 3 decimal places. So we have to use specifically small angle approximation. Okay, so we are given f dash x and stationary point. You'd definitely be knowing that stationary point, at stationary point f dash x is 0, right? So this is the information given to us. So let's take that f dash x, which is equal to 2x plus half cos x, it is equal to 0 given that x is alpha. So if we substitute alpha, if you know the small angle approximation, so what cos alpha is, what cos x or cos alpha is, so cos alpha is nothing but 1 minus alpha square over 2, right? So we are going to be substituting it there. So f dash alpha, if I say, it would be 2 alpha plus half. Now in place of cos x, because we are applying small angle approximation, so we are going to be substituting 1 minus alpha square over 2. Does that make sense? And this whole is equal to 0. What exactly we have to find? We have to find the value of alpha. Okay, so 2 alpha plus half, take away alpha square over 4 is equal to 0. Just quickly solve it. So it's going to be 8 alpha plus 2 minus alpha squared equals 0. Or we can say it alpha square minus 8 alpha minus 2 equals 0. Now let's solve for alpha using your calculator. You are going to be getting the value of alpha to be 4 plus minus 3 root 2. Or in decimals, because we have to take the smallest value, so we are going to be taking the negative value over here. So it would give us negative 0.243 to 3 decimal places, right? So this is what we have got for alpha. And A part is done. Now the point P 0,3. This is a point that lies on the curve. Now find the equation for the tangent of the curve at P. We have to find the equation of tangent at P, giving your answer in this particular form, right? So let's go for B part. So for B part, what the gradient will be? The gradient when x is 0. Why did we take x 0? Because point P is 0,3. So we have to find the equation of tangent at point P, and the coordinate of point P is 0,3. So what the gradient will be when x is 0? So let's find out f dash naught, because f dash is the gradient. F dash naught is going to be 2, just substituting 0 there in the equation, plus half cos 0. So we're going to be getting 2 times 0 is 0 itself, 0 plus half, cos 0 is 1, so half times 1 will give us half. That means gradient is half. Okay, because we know the gradient, the value of m is half and point P is 0,3. You can find the equation of tangent by using the formula y minus y1 equals m x minus x1. Or you can also use y equals mx plus c, because your x coordinate is 0. So y minus y1 is 3 equals m is half x minus 0. If you simplify it more, you're going to be getting y minus 3, or we can say 2y minus 6 equals x. From here we can say we have to write the equation in this form. we have to write the equation in y equals mx plus c form. Okay, so we can say it would be y equals half x plus 3. So we can definitely eliminate this step. We need not to do this. We can directly say just, expand it or maybe multiply it inside, and we can get our answer just by moving things around. So this is our final answer. Y equals half x plus c, or if you want to write in decimals, y equals 0.5x plus 3. Okay, let's match with our answer. So the first was negative 0.243. That was correct. And the second is y equals half x plus 3. Perfect. Thank you.